And there we go. I think we're all set. Welcome to my first stream. My name's Matt. I'm a web developer, dabbling in a bit of game development. And I hope this is just a bit of fun. This is something I do as a hobby, just to sort of relax in the evenings. Something a bit different from work. So I was tinkering on various little things and realised at some point that actually the little projects I'm working on are the sort of thing I would have been interested in watching myself. And so why not stream them and see if that's a good time or not. I will preface this by saying I'm not an expert in any of these things that I'm about to be doing. So if you're here to learn something, I'm perhaps the wrong person to go to. But, you know, maybe we'll just relax and work it out together. I guess it's a bit of useful background to know that I've done a little bit of stuff before. So I've got this small project that I set up where I've grabbed the this Brachy's platformer assets. It's available freely online, and I've used that to just make a little sort of mess around platformer using the Vulkan API to do all my rendering, mini audio to do sound, GLFW to manage windows, and learned a lot, had good fun. It more or less works. So if I come in here and we'll just run it quickly, you can see it. My little guy is animated and he bobs, and if I jump, I don't know if my mic will pick that up, but he makes a little boop. The game updates, and if you fall off you die. And honestly that's as far as I got with it, because I then realised I don't really want to make a platformer, but it served, I think, as a sort of proof of concept to myself. I understand how to draw things to the screen, write something that will update. We'll probably end up looking through some of the source code for that, not least because I would have forgotten how much stuff works. But like I said, I'm not interested in writing a platformer, and that's kind of getting to the stage now where we're not just writing a rendering pipeline, we're into writing a game. So I figured let's take a step back and write another game that I'm a bit more interested in actually playing. So I've landed on this kind of simple idea. Over here I've made a new little project. I'm calling it Flectris. What I'm imagining is you're going to play Tetris and we'll come up with fun little twists on it. So the simple one I've got in my head right now is that you'll be able to edit the tile set you're going to play with. So you can play with the classic Tetris pieces and it'll play like Tetris, but you could also come up with, you know, increasingly horrible tile sets to make it more and more difficult. I'm going to try and keep things nice and small in scope, so I think it was a good move on that Brachy platform to keep everything very pixelated. I think it just makes the art side of things very simple. I think we'll do the same here. We're going to do something very similar, so if you are curious, you want to look up that Brachy platformer source on my GitHub page, you can totally go find it. It's all public. We're going to set up quite a similar Vulkan rendering pipeline. I'm going to resist the urge to just copy paste it across and mess with it, because I think I learned quite a lot writing it out. It's not the first time I've gone through it, and every time I've gone through that sort of process I've learned more. So that's the goal that I'm setting. First will probably be to write a somewhat sensible rendering pipeline so we can get pictures on the screen. And then I think we're going to work out how to make this actual like game loop run. There are some things I want to do differently this time. So in fact, maybe it is interesting if we go have a look in the Brachy platformer code. My goodness, where would I be looking? It's been a while since I actually wrote all of this stuff. It would be an animation. No, so that's specifying the different frames for the different animations that we want. Game overlap.odin. Somewhere in here, we go to drawables. This is where, so on the CPU side, we are generating out just the list of vertices and things that we want to send. I guess if we go to where we call get draw data, maybe, and of course it's not working in the OLS, something like this. We're about to draw a frame. we take a list of drawables. So I guess it's actually the point where we call draw frame that we're interested in. It has this list of drawables, which then takes this game to drawables, which is up here. There we go. That's the bit I was after. For just pure simplicity, the first time around doing this, I just rendered things in the order that they appeared. What this ends up meaning is that the order that things get added to our sort of list of drawables is really relevant, because if we end up drawing something after something else, it would come over the top of it. For the purpose of this project, I kept that really simple, so it wasn't hard to keep track of, but I can see it doesn't scale well, and I know from the docs that you can do Z buffer checks to do this in a more sort of scalable way. So I am going to do something similar with 2D rendering using the Vulkan API to what I did in this project, but I will also be trying to add a Z buffer to do this comparison in a way that makes more sense. Was there anything else interesting? Something else that is missing from the Brachy programmer stuff, if you notice, there's no UI of any sort. There's no text of any sort, and again, that was done deliberately just for keeping things super simple. I've got a rough idea for how to draw text. I mean, drawing text I don't think is very different than just drawing textured quads, but I haven't really thought too hard about how you organize that to make it all easy to work with. And drawing UI, I have literally no idea how to go about at the minute, so that's something to come back to at some point. But I think that this Tetris idea plays nicely into that, because coming up with a little tile set editor is obviously going to involve a bunch of text and a bunch of buttons and a bunch of UI layouts. So yeah, that is the plan. I anticipate this probably ends up taking quite a long time. I've got a whole bunch of docs that I'll be referring to. This is stuff that I found useful the first time around, I guess, just to flash it up. So this is the Brachy platform stuff. It's all public, so if you've seen this, it's piqued your interest, you can totally go and learn from this. I will point out once again, I am not an expert, so if you do take anything out of this and it's a bad idea, you do so at your own risk. But as you can see, it does work, so that is what it is. Then I think another thing that will be useful to refer back to is the Vulkan spec. I do find it super slow to use in the web browser, so maybe when we get deeper into it, I'll go download a PDF and we can do it all locally. But obviously contains every little detail of every little thing. I didn't really follow the Vulkan spec other than when I got stuck to try and unpick issues. So one thing we might see more of is this Vulkan tutorial. I know this is the old Vulkan tutorial, and there's a newer, I think, VK guide. Just for the sake of not confusing myself, I'm going to keep referring back to this same thing. It works, so I'm going to keep going with it. I think there are sort of neater ways of doing things that the VK guide lays out and avoids a lot of boilerplatey stuff. As we're going to see, there's a lot of boilerplatey kind of form-filling programming to get this project started. But I'm thinking maybe this is a bit like eat your vegetables. It's good for you. You need to know how these things fit together. And once we're more comfortable with these things, maybe I'll go back and try VK Guide and learn how those sort of smoother things work. But if you see this coming up semi-regularly, that'll be why. And like I said, I'm going to use GLFW for managing windows. This is probably where we're going to start. I am far from an expert in GLFW, so we'll be messing around with it till it does what I want it to do. But like I said, the Brachy platform stuff I wrote works. I am planning this time to kind of look through this a little bit more and see if I learn anything useful. So maybe we can do that together, and that could be a good time for everybody. But you know, it's a library with quite a lot in it. So if we miss something, we miss something. But yeah, this just gets around all the headache of having to like work out. For example, one thing, if you were to do this properly from scratch and you were just doing it with the X server, I think it ties you to using X11, which I might want to one day use a Wayland Linux distro. And it also means that when I get to the end of this, well, I guess a soft goal I have in my head would be to be able to cross-compile this program to Windows and then be able to play my game on Linux and send it to my brother and have him play it on Windows, and everyone have a good time trying to beat each other's high scores. So, relatively modest goal, but I think there's quite a lot of work to get to that point. And GLFW just simplifies the platform layer side of that. Again, maybe one day in the far future, I'll take more interest in the platform layer and come back and try to work out how to do all of this stuff more sensibly, but I don't think it's where the interesting stuff is. So we are going to just try and blitz through it. I guess the other choice that I've made that is potentially interesting is that I'm using the Odin programming language. It's not exactly a super niche language. Like it's out there, people are using it and know about it. But it's not C. It's not like a language that's absolutely everywhere. Reasons for using it are mostly that it's quite C-like in that it's very simple. It doesn't do a whole lot, which I found it to be kind of a refreshing when I'm doing sort of programming for fun. Certainly, I've tried programming in Rust, and while I can see that the memory safety aspect of it must be useful in certain circumstances, when I'm just programming nonsense for fun, it just feels super in the way. Whereas Odin fully embraces that, do what you want, and if it blows up mentality. I've also done a fair bit of sort of fun programming in Zig, and I think Zig's a super cool language. I've just found that Odin makes life slightly easier. The Zig build system is obviously very cool, but while writing very little simple programs, it just kind of felt annoying and in the way that I had to keep worrying about this build system. Or you end up having to run a load of command line stuff that doesn't feel very ergonomic. I also found it was constantly shouting at me to fix unused variables while I was sort of debugging things. Whereas again, Odin will just let me run things, so that kept me happy. I guess that raises why not just use C, and I think the main reason to not just use C is multiple return values. I really like that Odin gives you multiple return values, and you can avoid the whole headache of having to pass in the multiple in-out variables, or having to make structs for everything. I don't know if I use it super widely, but where it does come up, I find it's very nice. It gets used in a fair few places in the kind of wrappers that are nicely vended in with the kind of standard Odin distributions as well. So appreciate all of that. It makes life just easy. It makes programming fun, and that's what we're here for at the end of the day. So I guess maybe a useful thing to do would be to let's make a little plan. Oh my god, up here. So Tetris, but what did I said? Tetris, but you can pick your tile set. What is the plan? How do we make progress towards this? I guess step one will have to be being able to make a window. So I'm going to say make a sensible window as well, because I think one thing you'll find when you start using GLFW, you can make a window that's some fixed size and not resizable, and you can't close, and sure, that's a step ticked off, but it's not useful in the slightest. So we're going to say make a sensible window, which means registering a few callbacks. After that, let's try and get to draw a triangle. If you've ever played with Vulkan before, you'll know that's not as trivial as you might hope. But it is what it is. We want to know how things fit together. You have to step through it all. Draw a triangle probably could be broken up, but it'll involve things like setting up the correct sort of screen, what the right word be, kind of initialization steps, so that you can draw to your swap chain images. It'll require grabbing the correct physical device so that you can actually dispatch work to queues on a GPU. Right, there's a bunch of stuff in there, which is all pretty interesting, but like, there's a lot of it. Once we can draw a triangle, I would like to say the next thing to do is draw textured quads. So if you've not done any graphics programming before, a quad is just 2 triangles. So you group a pair of triangles and you make a little quadrilateral, and then we can apply an image over that. I'm planning, I think, at this point to do this with what do you call it? I'm gonna call it like nearest neighbor filtering. If that's the wrong name, then I apologize. But basically, without the kind of like linear interpolation of pixel values, I'm going to keep everything very retro looking, just so I don't have to worry about anti-aliasing settings and things like that. So once we can draw a triangle, we can draw a quad. Is it worth planning any further ahead than that? Probably not. I think we take that as a good starting point. That probably makes up quite a lot of streams and videos, to be honest. So we will see how that goes. How do we want to structure our little project? So I know that Odin does everything in like directory-based packages. So I'm gonna make a main for my executable. I found out I really like the directory-based packaging, just 'cause it means that you can kind of split things out really trivially for kind of reorganizing things. So let's take advantage of that. We'll have a main.odin, and can we? Well, Christ, can I remember how to program Odin for a start? Let's start out with just a hello world, just to check I've got things set up correctly. So we've got a package main. Maybe to define, I don't know how familiar people are going to be with this, so double colon is to say that this is a compile time known value, so we're going to say that main is equal to this compile time known value, which is a procedure that in this case we'll call format printline hello world. I think that should work. So if we go ahead and do Odin run main, and there we go, hello world. Now, another thing that I'm probably going to want to be able to do is to be able to just do a build which will output a main.bin that I do not want to commit. So I'm also going to just take a step back and add a git ignore. Oh my god, where's it gone? Git ignore, and we're just going to ignore everything that has been. So we come back here, we can just check, and yeah, we don't commit the bin. Right, so that feels like a useful start. I guess the next thing to do is try and make a window. Let me just do a quick commit for that. I'm slightly worried that basically I think there's quite a good chance I'm going to mess up the GLFW stuff, so let's set a little, like a quick save that we can jump back to if we really make a mess of things. We've got the GLFW stuff here. Obviously the world is going to look slightly different because we are in Odin land, but one thing that is nice is that we have this vendored in GLFW stuff. This is just a set of like wrappers that I guess have been sucked in to the standard library. You can see this is the sort of thing I was saying about how, you know, like they've wrapped GLFW functions that take in-out arguments and replaced it with a nice Odin function that returns multiple values. That's what this is doing in here. So it's slightly more ergonomic to use. If I remember right, I think that I've got this just installed system-wide and it all just works. I'll be honest, I'm just going to worry about it as little as possible, and as long as it keeps working, I'm going to call it good. But yeah, let's get started with this. So we've essentially included our GLFW headers. We're going to not worry about all of this stuff in here, and we're going to pay attention to this. So before we can use GLFW, we have to initialize it. On successful initialization, it will give us true, else it will give us false. So I think the plan here is, like with so many things, if you don't know really well what you're going to do, just do it and do it messy. So we're going to do an init. This is actually something that is useful to know, I guess, from the way that Odin does these like C wrappers is you can do this thing with a link prefix. So if we come and look here, because C has no sort of namespacing, people kind of manually namespace by prefixing all of their functions. Odin has sensible namespacing, so when I want to use an imported function in here, I've imported GLFW. You can specify the name that you want to use up here, right? But it defaults the name of the package to this last bit. And so we're going to call GLFW dot to get access to everything in its namespace, which means that if it just did it plainly, you'd have to do GLFW dot GLFW init, which is always a bit gross and ugly. So this link prefix thing is a little bit of cleverness to say, just strip that off, because we know we're going to handle that sensibly. And it's going to return us a bool. It doesn't use the enums. That's interesting. One thing I have found that I think is perhaps slightly unusual, but I found it's useful, again, in the context of writing code that I don't understand very well, and I can't plan very well ahead for, is instead of splitting things out into functions, it's to split things into these little scopes. It means that I can still name stuff locally. So like in here, I can do res equals GLFW init, say. So we can do something like this. And I don't have to worry about the fact that I might want to use res again down here because it's scoped within this little block. But I can still read it top to bottom. I actually found when I first started working on all this, I split things out into lots of little functions with nice names to try and make things readable, and I end up just getting super lost and having to refactor a bunch of stuff. So we're going to try that and see how we go. It may prove to be a mess, and I may change my mind about these tab markers because that's potentially annoying, but again, we will see. We'll say in here, so if res is not equal to true, which I guess we can do with if not res, which again, I guess we can do this more nicely. Let's do okay. So if not okay, I think there is a built-in panic. So we're just going to have everything blow up. Again, just for the sake of keeping things simple. If it doesn't do what I expect it to do, die. You know, we can come back and refine that later if we want, but this is just saying, you know, we expected this to just fucking work, right? So let's just expect it to work, and if it doesn't, blow up. So let's just do something like this. Now, we have got a bit of a question. So you say in here that you need to terminate GLFW, which will close all your windows and free a load of any memory that's allocated and stuff like that. I think there is a good argument to just say, actually, you know, we're expecting this to happen in sync with our process, starting and stopping. So there may be no point. But I think I might just do it, at least for the kind of windowing and rendering logic. I don't think it's strictly needed, but I also don't think it will take very long, so I don't think it will be very noticeable. And I think this may simplify the world slightly if we decide in the end that we would like to do something where maybe you can like change your graphic settings, hit restart, and everything goes down and up again. So we will do that. We can always take it out. Let me stick another print line in here and just say fine, and just check that that is still running Because like I say, it has been quite a while since I wrote really anything like this, so I'm slightly worried that things may end up being a struggle. I'm just having a look at the capture actually, and that looks a bit small. So shall we zoom it in a little bit? Does that look a bit better? It's going to feel slightly odd working like this, but we'll see how that goes. There's not a lot of point doing this if people can't read it, is there? Okay. So, we have initialized, we have terminated. Setting an error callback. Basically, we would like to get a nice printout to standard out if it dies. Again, this is the sort of thing that could get more complicated later, but I don't think it will. Trying to remember if there's anything tricky with this. So you make a void error callback, you call GLFW set error callback, and you make it equal to error callback. I think that can quite happily live in this init block. We're gonna need to make an error callback. So let me just say in here to do actually work out what that error callback looks like. So I think we might have to do a C style function. So Odin functions by default get a bunch of stuff passed into them. So they have a context passed into them that has a default allocator on it, and other things like that that helps to make the language ergonomic to use, but also like makes it not exactly the same as a C function. So you can tell it that a function needs to be just a straight C function, so you can pass through stuff like this. So we'll think about that in a second, but what I want to do, I want to call this set error callback. So in here, glfw.set, let's see, take advantage of this to make sure we get the right stuff on it. And it gets a callback function, error proc, returns an error proc. Oh, it returns the error proc, does it? Callback functions must be set so GLFW knows how to call them. The function to set the error callback is one of the few things that may be called before initialization. Interesting. To let you be notified of errors both during and after initialization. So maybe we want to move that above. Okay, that's kind of cool. Right, so that's saying actually I can do this up here, is it? Like that. Except that it's going to need the function passed in. So let me go ahead and say down here, this is my error callback. It will be a proc. I think you do like this to say that it's a C-style procedure. Which possibly means we're going to have to do something to say I want to like go grab the context for it. Can I remember how you do that? I cannot remember how to do that. Can we go into Odin language reference? And we'll go have a look. There's something here for default context. That looks like what we want. So what is this here saying? Explicit context definition. Things that do not use the Odin calling convention must explicitly assign context to something within the body requires it. Proxy. Try commenting the following thing out below. We have to import base.runtime to make that work. Oh, did I just close my tabs? I did. Whoops. There we go. So we come back up here. If I remember right, I think it's called base runtime. Let's just, there we go. And then if we go runtime default context, why did that not work? Context equals runtime.default context. Runtime.default context. Oh, sorry. You go in there. You come up here. Everything's good. Now then, can we do a bit of jumping around to find out what this type actually is? So we've set error callback, takes this thing in. Okay, so that's the type that we're going to have to be. So let's grab you, stick you in there. So You, sir, are a C-style function that takes an error C-int and a description C-string. We don't have C-int. Can I do this? I cannot do this. Can somebody please remind me how to use C-int? Is there anything in here about C-interop? There is not. Specific integers is not what I wanted. So C-string, I remember. So C-string, basically, Odin strings are normally a pointer and a length. So you have to specifically tell it if you're going to be using C-strings because they're null terminated. I cannot remember what you do with ints. Your operators, enumerations, raw data. I'm going to see if I can literally make you an int and see if that just works. So we pass those two in, and I think now we've got that context, we're now able to do, I think there's an ePrint line for print standard error. And we're going to say GLFW error. Sorry. GLFW error. Error and description. Do we want to kill the program if that happens? Maybe. I won't for now. Because actually I don't know that I've ever seen one of these come up in the wild. But we can certainly do that if it's seeming useful. Cool, we do have a problem. Cannot assign the value because it's an I32. Interesting. So instead of this int in here, we want to make it an I32 explicitly, which I guess makes sense. I guess a C int is going to be an I32 or I64 depending. Is that even true? No, a normal size int is always going to be an I32, isn't it? If it's not something really old and strange. Let's run that and see if it crashes at runtime, and it doesn't. Good. That's nice. Cool. Let's keep going. So we would like now to create a window and a context. We're not going to create a context because we're not going to be using OpenGL. So we're going to have to do a bit of skimming around those bits, but we are going to want to create a window. There's probably going to be a bit of thinking about where we put our window. So one thing that I did in the Bracky platformer example that I was writing is all my window initialization and management is bundled in with my renderer, which works, you know, for the kind of simple behavior that I was doing. It did occur to me at some point that it'd be quite nice to implement some sort of like screenshot testing, which I think you can totally do. You can obviously do with the Vulkan pipeline, right? You have control over everything. So we might give it half a thought if we can to try and separate off the window behaviors from the rendering behaviors, because obviously if I'm doing screenshot testing, I want to be able to run a load of logic without having a window in. So maybe whether they're separated or not, at the very least making it so that the renderer is tolerant of not having a window, so that I can have a mode where I just output an image instead. But yeah, for now let's just do it all straight into main. Do it all very one-dimensional, and we'll see how it all goes. So let's have a look then. So creating a window, call create window. I will pull out, only because I think they're useful to have. So we're going to have up here, I guess, window width and window height. And let's go ahead and make that 640 by 480 of standard aspect ratio. So we're in here now, and we would like to do something like, what do I want to say? Create a window. So we've got GLFW, create window. What does that give us? Width, height. title, monitor, and share. I think we can probably just pass nil pointers through for monitor and share, because we're not going to do anything special with those. Can I come in here and we'll grab all of this? So that's all of our fields. We're going to do width is window width, height will be window. My God, typing is proving a problem. There we go. Window height. Title. What do I want to call it? Let's pull out window title. We might end up finding this string appears in a couple places. Window title. So again, something that's nice with that string C string thing. I think Odin literals are null terminated in memory, so you can pass the literal to either, and it'll just convert because it knows, or I guess is it null terminated in memory. It knows if it's passing something C string, then it needs to allocate that extra room for the null terminator. Let's call you Flectris, like so. Which gets us down to here, and like I said, I think we can then just do something in here like nil nil, and that I think should work. GLFW create all of that. Okay, so it doesn't return us out a result type, does it? Instead, it gives us just a handle. If that handle is null, and is that true for you too? You simply give us a window handle. How do we want to handle that then? So again, maybe this is gross, but the way that I handled stuff that I'm going to want everywhere previously is I just made a thing up here called global context. So global, and we define a big struct. I think I might just go with this for now. So we'll have something like GLFW window. So I think they're going with calling it window handle. I think this is one of those things. So yeah, in GLFW world, it's called GLFW window. But then they use pointers to it everywhere. They only ever pass around pointers, so I guess that's why they've gone with this. It's a raw pointer. I guess because we're using a C library, maybe it casts it in a weird way in other internal stuff, or other things will take it in. Alright, so let's go in here and we'll just do that our global context window is equal to this. And if global context window at this point is equal to nil, we will panic and say that GLFW create window failed. Cool. These window hints we're going to have to do slightly differently because we are not using a GLFW context. I don't know if this gives you a link somewhere to what you do if you're using Vulkan. It does not, so we may have to go just look at our other one. Cool, a window flashes up and it doesn't error. Let's do another just quick save, because like I say, I'm very cagey that I'm going to end up breaking things and wanting a little quick save point to go back to. Let's have a quick look. So if I remember right, I think actually this also uses GLFW. This is probably actually how I ended up deciding to use GLFW. Are we under setup? Maybe base code, presentation. Possibly not. Although Windows Surface. There we go. There's a bunch of GLFW stuff. Oh my god, I can't remember how all this works. It feels like I'm looking at this for the first time. create Win32 service cache. So this is the like Vulkan library side of it. So I guess they've already created their window at this point. Okay, let's just go look at our cheat book in here. In fact, actually, let's do it in our editor instead. So if we're in here, we are probably looking for the renderer. Somewhere I have an init. This all looks very familiar, right? I'd be curious actually if this is literally the same as what I've just done. There we go. So we have to set window hints. So before we create the window, we set window hints. We tell it no API and resizable. Resizable I think is self-explanatory. Although I think we're going to set resizable false at first, because there's some stuff that it makes the swap chain stuff a little bit more difficult than you'd guess. But let's yoink that. Head back in here. So before we make our window, let's use this. We tell it no API because what we're telling it there is don't use a GLFW context. I'm going to set that to false. I'm slightly surprised that takes a GLFW false instead of just a bool. It takes a window hint bool. Why are you different? Excuse me? You do take a bool. It's a GLFW false just mapped onto a bool. Oh, fun. So actually I can, instead of that, can I just do false? Okay. So we can now check in. Yeah. Cool. So there's no errors. The reason it just flashes up is that we don't have like a while true to keep the program running. So that's not a worry. But that seems to be working like we want. So now that's working. When a window and context is no longer needed, we destroy it. Once it's called, no more events will be delivered for that window and its handle becomes invalid. I think similar to what I was saying about the GLFW call. I don't know if this is strictly needed because we expect this window to basically live for the length of our entire program, but it can't hurt. I think what we're doing is so simple, it should just happen. So let's do that, and I guess at the point that we do that, it doesn't hurt to also set our window pointer to nil, just to avoid us, well, just so we can detect that we no longer have a valid window pointer if we care. Let's run it. It worked. And so what did we do in there? Should we just say whip window? We know a bunch of these. This is something actually, if you follow this for any amount of time, you'll realise I keep a very messy Git history. So that may annoy some people. I prefer to think of it as like quick save points that I can get back to, rather than as kind of like self-documentation for other people to read. It does mean if I end up bisecting back through my history, things might be a little bit confusing, but you know, we take that. So where are we up to then? So destroy window, we've done. We don't care about all of this stuff, although we will have to do something similar. Maybe we do care. This is the part that I remember being messy. It's something, so let's just sort of sketch it out. So in here, we're going to need something to get what's the right way to say it? Like to locate the procedure addresses. So I'm quite fuzzy, to be honest, on exactly how this works. But when you have a Vulkan instance that you're using, I guess what you're really doing is you're sending requests off to the Vulkan loader that you link against from the Vulkan library, and the Vulkan loader then manages all of the difficulty of managing different versions of the Vulkan libraries and of managing your client device drivers, managing the fact you might be using multiple devices, managing the fact that multiple different programs may be using the same device. I think that all gets put through the Vulkan loader, I think you can set it up so you cut the Vulkan loader out and you get access directly to the devices, but that means you can't use layers. And we'll see once we get onto it. I think layers have saved my butt. They catch every little mistake. So, well, they don't catch every little mistake, but they catch really silly mistakes that would have been a pain to debug. So we will be using the layers for validation. So it will be going through the Vulkan loader. But of course, what that all means is we first need to set up our Vulkan instance and our Vulkan loader and all that jazz. So I think this is going to end up being another one of those things that we want to live globally. I might go with Vulkan Instance like this. Can I just call it Instance? Possibly, but I think I'll confuse myself. So I'm going to go with VK Instance. We'll come up here. And again, this is one of those lovely vendored libraries, so we can jump into it if we really want to. But yeah, there we go. So we're going to have a global Vulkan instance. I guess at this point it's saying that we would like to do that step to go off and initialize it. I think this might be another place to go and just rip code from the other project, because I think this is one of those you just need to know how to do it things. This is all stuff that we're not going to worry about too much. There we go. So maybe what I'll do is I'll yoink this out of here. Whoops. Do a proper paste. And let's read through it and see if we can get our head around what we were doing. Because like I say, it's been a long time since I wrote this. So get proc address, similar to the other one. Was it interesting that I did it locally in this case, and not in the other? I might pull this out. So I have it in my head that I might want to pull these things into different files for sort of organising them in a bit. So we're going to initialize our Vulkan instance. We're going to call this VK load proc addresses function. This is complicated. I don't know if we're going to worry too much about the details. The thing I remember being gross, oh my goodness, is my get proc address. Oh God, what have I done here? There we go. So my get proc address down here, you have to do this nastiness where we're going to be grabbing a whole bunch of stuff. Okay. I will come back to this, but I'm dying for a wee, so I'm going to leave a little gap, and we'll come back when I can think a bit more straight. And I'm back. Always the risk of drinking a cup of tea before we start. I don't know if you can hear it, I've had a bit of a sore throat recently, so I've been sipping away. It's starting to catch up to me. Okay, so what we're saying, we have this get proc address function. So if I remember right, the way this thing works is we have to provide the program with the function that we want our instance to call so that it can go and look up functions by name. So this here is a pointer to our Vulkan instance that will be the place that knows how to look these things up, and the name, which will be the name of the function that we actually want to be able to call. And I think there is stuff in this that is platform specific, so you can write this all yourself, and it's all in the Vulkan spec. It may not even actually be all that hard, but GLFW has a bunch of stuff that makes it all kind of trivial, right? They handle all of the platform specific stuff, so we don't have to. And again, maybe that's interesting, but for what I've done so far, for the simple things I've done, it's just worked. So let's hope that lasts. I'm curious what I've done here with this context dot user pointer business though. So I've got this global context already. So if I come in here and I just replace that with GC, does that not work? So this user pointer is one of those things I was saying. So the Odin function has a context that gets implicitly passed into it, which includes things on it like an allocator. So you get a kind of a neat default allocator that you can specify what you would like to use instead if you need finer control. And then user pointer is kind of a way for us to pass whatever we want with it. I'm slightly confused about the fact that we're using it here. So I'm just going to try not using it. And maybe it blows up. Maybe there's something past me worked out. But let's see how we go. Assuming that it's not something we need, what does this line actually say? It says we're going to take the raw pointer that gets passed into this function, and we're going to cast it as a pointer to a raw pointer. And we're then going to, oh my god, what do you call it? We're going to dereference it. We're going to take the actual value at that place. It's confusing. So what it's saying is that we've got a pointer to a pointer, and we need to get just the pointer. And then once we've got that pointer, we're going to assign to that value this get instance proc address result, which I think, do you return me a function? You return a raw pointer. I think that'll be a function pointer. So we're lining up the function to go and look up Vulkan functions, and we're going to stick it onto our global instance. Because we've copy pasted this stuff, we do have a bit of stuff in here to go and mess with. App name might actually be a better name for this window title, right? So we'll go do that, and then required layer names. I'm curious. I'm guessing in here that, where's it gone? Oh my god, typing. Required layer names, which is nya, is just the validation layer when Odin debug. Cool. Shall we just copy that over as well? What's required extension names? We need the swap chain extension, exterior, or extension descriptor, indexing extension name. This is the problem with these sorts of programs. You don't really understand them very well, and you don't touch them for a long time. It all just reads like nonsense, doesn't it? We are going to need that later, but let's plumb it in later. For now, let's just not pass those in. Okay. So, this stuff we've copied over, what are we doing? We're doing that load proc addresses. It's, like I say, slightly messy, but I'm pretty sure it should work. I guess this is the first Vulkan function call that we've seen. So if you're not familiar with the Vulkan function calls, they're all slightly nasty. I assume it's a consequence of them having to make everything so like platform independent. Or maybe it's just bad library design. They feel very clunky. But so what you have is each time that you want to make something, you have to create one of these info structs. And what you'll notice, they all have this S-type, like struct type field on them that is an enum value. So this one, we can probably go look it up. It'll be a number, right? There you go. So the 0th one gives you the application info. And what it means is that from just a plain struct, it can know what function you're calling. You have to line that up, and then you end up having to do this form filling. So in here, for example, we have to give it the application name, I'm assuming we don't have to give it a length because it assumes it's a C string. In fact, can we look that up? Yeah, C string. An application version, I don't know why we need that. An engine name, which I don't know why it needs. An engine version, which I don't know why it needs. And this API version, which we do care about. So I think this means when we start up Vulkan, it will attempt to grab an instance that is capable of supporting at least the version that you've requested. I think they're up to 1.4 now, or maybe 1.5 is either out or coming soon. I'm going to target 1.3 because when I looked it up before, it's basically available everywhere on desktops. And I don't really know what the difference is, but I know that people say a lot of nice stuff got added between 1.0 and 1.3 that we might want, we might care about. I think the main thing that it means for us, there's a bunch of stuff that used to be available as extensions that I think we can now just call because they got absorbed into the kind of core library. So it makes things slightly neater. You'll notice it also makes the Vulkan docs quite messy, but such is life. So we'll make our application info. Then what are we doing here? We're calling get required instance extensions. I think that, again, what this is, it's GLFW handling the fact that different platforms will require different Vulkan extensions. So there will be sort of, I guess, like X11 related extensions to do with things like getting the bytes that we need to write to update images on the swap chain, and synchronizing image presentation and all that sort of stuff. Again, it's all covered in the Vulkan docs, you can do it yourself, but this has just worked for me so far, so I've not looked at it anymore. And then this is the kind of classic pattern for all the Vulkan things. We're going to see a lot of this. You first create a thing create info, which has a struct type on it called thing create info. They tend to have a whole bunch of fields on them, and then you call create thing. So this is going to actually create our instance, which, what are we passing into it? We pass into it our application info, and then our enable extension count, which is a castu32 len GLFW required instance expression. So GLFW required instance expressions will give us a list of strings, I'm guessing. And then this is a pointer to those strings. Why is it a raw data? So I think it's probably going to be a raw data because this probably gives us a... Yeah, so this gives us a slice back. So this is another one of those where... a nice thing working in Odin, it has a built-in nice slice type, which is basically just a pointer and a length. And in a bunch of places where we need raw pointers, we will just call this raw data, which strips the length off, which gives us the pointer. And lets us interact with C code nicely. And then we can call create instance. So that should hopefully just work. And if it doesn't, again, same mentality, blow up if it doesn't work. Let's see, because that actually might not work because of our change to this thing. Window title, I thought I'd updated that, but I'd not. So we have app name in there. Cool. It didn't complain. Maybe it's a good thing that I'm recording. I think there's a chance when we start calling Vulkan functions, this may blow up. So I guess I'll have to look back and remind myself I have made a change here from what I've done before, but fingers crossed it's fine. So where are we up to now then? So we've done what I think is kind of the comparable step to the making an OpenGL context. I mean, for what it's worth, I've only ever done a very little bit of OpenGL. My understanding is that basically this OpenGL context stuff sets up essentially all of the boilerplate that we're about to write by hand. And it gives it a bunch of stuff that they thought were sensible default values. So where we're going to write out our pipeline very explicitly, OpenGL gives you a pipeline that has more or less sensible values in it. And then you update those values to kind of tweak the behaviors. I'm sure it's, you know, clearly it's a system that can work very well, and you can get to know your way around it very well. I certainly found from a little dabble that it felt very magic. Like it felt like I was really just using a library that was drawing things. I didn't know how I was grabbing devices and how all of the swap chain stuff was all working. It felt to me like if I was going to do that, I might as well be using Unity or something. We may find that we peter out and run out of steam and struggle to get through all the Vulkan stuff, but we've done it once before, so I'm reasonably confident we should be fine. Okay, so that's OpenGL. We're not doing OpenGL. Checking the window close flag. Each window has a flag indicating whether or not the window should be closed. So maybe this is a useful point to add a sort of main loop into our function. So we have main. Main is running. We are doing a bunch of stuff. And then we're going to get down here. And let's just say in here, main loop. We're going to do... Can I remember how you do it? I think it's literally just for. In Odin. So that runs forever. You see, we now have our fixed size window. And if I click to close it, you'll notice it does not close, which is a shame. So you have to come in here and kill it off with interrupt. And the reason for that is that we've not hooked this thing up yet. So how do we want to go about this? What does it say in here? Each window has a flag indicating whether the window should be closed. When the user attempts to close the window, either by pressing the close widget in the title bar or using a key combination, this flag is set to 1. Note the window isn't actually closed. You're expected to monitor this flag and destroy the window or give some kind of feedback to the user. Cool. So while not, GLFW window should close window. Oh, fun. I wonder what window should close actually does. There's some stuff in the docs about it. If you can set it yourself with GLFW set window should close with an int window closing and close flag. Is there anything interesting about this? Is this just saying more of the same what we've just seen? While not, window should close. So I guess it literally just has a bit of internal state. Cool. So let's come in here and we'll say for not GLFW window should close. That's why it's not just a global thing, it's going to be per window, isn't it? So you're going to need to take a handle on our window and you return us a boolean, which we cannot. And I think that should actually... Is that making that work immediately? It doesn't. Why does that not immediately work? Checking this flag. Can be notified when the user is attempting to close the window by setting a close callback with window close callback. The callback will be called immediately after the close flag has been set. You can also set it yourself when you press a key such as the escape key. It looks to me... My god, can't use my computer. Like that should be working. So while it shouldn't close, let's do format, print line, frame, and then we'll come out of the for loop and we're closing. So frame. Interesting. We've missed something. I don't know what though. For not, GLFW window should close on this window. How annoying. This seems like it's really simple. I don't think there's anything in there that we could have missed. Okay. This is after we've created our window. So if I come in here and say if global context window were nil, panic, this should be unreachable. Oops. But no, it works. What on earth did we do over here then? Sorry, I'll be back in the main file, won't it? If not, GLFW window should close. Ah, is it because we're not calling poll events? I would have thought that didn't make a difference, but I guess maybe it does. So I think poll events is its way of saying so I think internally it's hooked up into the operating system that you're using, so it knows when different events are firing. It's putting all of those into a queue, and when you call poll events, it will flush that queue and like handle them. I think poll events is the one that keeps the program running kind of in the foreground. I think there's a different one that will basically sleep the program until there's an event, so that it doesn't hog so much resource. But for a game, we do want to hog resources. Let's see. So does that one now work? Hey, interesting. Cool. I didn't realise we would need that. So that's good to know. Maybe we just needed to keep reading. Maybe it will tell us this, but nice. So we've got a more sensible window now. You probably saw in the other thing that I had that little running bit of state as well back in the Brachy version. I'm going to wait and see if that's needed, right? Because it's one of those things that the tutorial told me was needed, and I just trusted it. So let's get bitten before we add it back in, I guess. Is there anything else in here? Yeah, no, it doesn't say anything about you have to wait for that. Okay. So this thing in here, receiving user inputs, we're going to have to set a key callback. We're a ways off needing that, so we'll come back to that in a bit. Rendering and reading the timer. I think we've got nice standard library stuff for reading timers, so we won't worry. Swapping buffers, we're going to manage ourselves. And poll events, what's that got to say about it in there? So GLFW needs to communicate regularly with the Windows system, both in order to receive events and to show the application hasn't locked up. Event processing must be done regularly. While you have visible windows, it is normally done each frame after buffer swapping. There are two methods for processing pending events, polling and waiting. This example will use event polling, which processes only those events that have already been received and then returns immediately. If instead you only need to update your rendering once you have received new input, you can do wait events. Useful for editing tools. Okay, cool. And then they've just got a thing down here giving us an example. Christ, quite a long example, isn't it? And they point you in different directions. Cool. I think that might be a good place to leave video one. We have a sensible window. We can move it around. We can close it. I think just for demonstration purposes, let's also go ahead and set resizable true. And we can see there actually that we get like, you know, a nice sensible window. I can maximize it. Okay, admittedly it behaves strangely because it's not being cleared to a color or anything like that. So it kind of just seems to grab hold of whatever's underneath it. But it is a window that is working. Nothing's crashing. There's no errors. we're going to keep this false for the time being, only because I am aware that, so spoilers for what's coming up in the future, we're going to need to allocate out swap chain images that represent the pixels in this area. And obviously, if the size of this window changes, the size of those images change, and so that whole swap chain needs to be updated. That is a thing we'll do relatively soon, but it is also a thing that, you know, we're not going to do immediately. So I think we keep it not resizable at first. And similarly, we'll come back and add the callback for handling keystrokes when we get into it, because again, if you look at that Bracky platformer, I've got a thing that was working, but I don't know that's the neatest way in the world of doing it. So we might want to have a more serious think about how we want to organise that. So where did we get to? Should we call this a minimally sensible window? Lovely. Grand. I think that might be a good place to leave it. So I will head over and just kill my recording.